IMS 2023 in San Diego. I'm Martin Rowe with the eWorld, and we are in the Anritsu booth, and Nanvit is going to describe this test setup. And Nanvit, what we have here is some equipment that can apparently test up to 220 gigahertz. And the reason we need that is there's a lot of talk about 6G and the research going on in 6G for that's running at 140, 150 gigahertz, something like that. There's also a lot of talk about D-band and G-band. And in those settings, engineers need to characterize their components,
right,
their amplifiers, their filters, whatever it is, and you've got a setup to do that. So why don't you tell us what you've got here and how it can address that need?
Sure. Thank you so much for the introduction, Martin, and thank you for stopping by. So yes, what we are showing here this time is actually our own Anritsu made millimeter wave modules that can cover from 70 kilohertz right up to 220 gigahertz in a single sweep. For every component, the fundamental device is basically a transistor or a diode. And everybody who's trying to do device modeling and characterization, they need to know how is the fundamental device going to behave from DC right up to the highest frequency that they can characterize. So the solution till today with all the customers was that since a broadband millimeter wave module was not available, they had to use waveguide multipliers. What do I mean by that? So that means they had to do one waveguide measurement in a pair, then dismantle it, put another millimeter wave module, again banded in nature. Likewise, do 3 to 4 waveguide measurement sets, and then they need to stitch it together to make a broadband measurement. But then because of the discontinuities, and every time you do a touchdown, you can, maybe most probably damage your device.
Sure.
The calibration and the measurement accuracy and stability is a problem because you are changing the setup every now and then. This solution that has been there in the market for the last 2 to 3 years for sure is the 70 kilohertz to 220 gigahertz millimeter wave modules from Anritsu. Now the customers can do the fundamental device characterization and modeling in one single sweep with the probes directly connected to the millimeter wave modules, and they can see a broadband response. Now, apart from that, a lot of customers who are not doing broadband device characterization, but they are trying to characterize, say, the D-band or the G-band amplifiers, right?
Okay.
And for characterizing those amplifiers especially, they need a high input power to drive the amplifiers in the nonlinear or the saturation region to see how good or bad they will perform. So the output requirement from the millimeter wave head, it's a little on a higher side, say of the order of plus 10 to plus 12. So what we did for those users that were using Anritsu solution is we made the hybrid solution work. So in the hybrid solution on the transmit side, you could have a VDI millimeter wave module. In this case, we are showing D-band, which is from 110 to 170 gigahertz. Now this D-band millimeter wave module from VDI can output power like plus 10, plus 11 in those higher frequency ranges. And then you can connect this to your device and the test, push them into the nonlinear or saturation region. But on the receiver side, you have a broadband receiver.
I see.
So this covers from 70 to 220 gigahertz in one go, right? So what potentially customers are doing right now is with this hybrid solution, all they need to do is have multiple bands of the VDI on the transmit side, but on the receive side, they go ahead and make the measurements in a broadband fashion.
I see.
Yeah.
Okay. And then what is this device you've got here?
Okay, yeah, that's a very good question as well. So Anritsu's own millimeter wave module, because we have to cover almost from DC to higher frequencies, we had to have a 0.6 millimeter coax connector. So what you are seeing here, right in the center pin, is a 0.6 millimeter connector.
Okay.
However, as I mentioned, sometimes the customers have waveguide applications. So you need to have a 0.6 to waveguide shim or interface, and that is what Anritsu landed up making. So if you see, you will see a waveguide engraved here. So that's the waveguide side.
Yep.
But on that side, you have a 0.6 connector that will mate with the 0.6 connector on our millimeter wave modules. You push that in, and now you have a waveguide measurement system in place as well.
I see.
So now the system can work as broadband system from 70 to 220 gigahertz, or you could utilize the system in a banded fashion as well.
Very good. Thank you.
Thank you so much.